welcome to this video where we're going to be going through the answers to the gravity questions on pages 33 and 34 of the Combined Science booklet. So in this first question, we've simply got to remember the equation that links gravitational field strength, mass and weight. So the equation is weight equals the mass multiplied by the gravitational field strength. Ensure you get the marks by using the words that are given in the question. Okay, a small ball weighs 1.4 newtons and the gravitational field strength equals 9.8 newtons per kilogram. Calculate the mass of the ball. So we're going to use the equation above, which is weight equals mass times gravitational field strength. But in this example, we need to know the mass. We therefore need to move the gravitational field strength to this side. So we always do the opposite. So instead of multiplying by g, we're going to divide by g, which gives us that weight divided by gravitational field strength equals mass. Our units are standard units in newtons and newtons per kilogram, so we can just substitute those numbers in. So the weight is 1.4 newtons divided by the gravitational field strength, which is 9.8. And if we work that out, we get 0.143 kilograms. The ball is thrown high into the air. After it's released, the ball moves up and then back down in a vertical line. The free body force diagram in the figure below shows the forces on the ball at one point in its flight. The force arrows are drawn to scale. Explain what's happening to the ball at this point in flight. Well, firstly we need to identify at what point is the ball in its flight. We see that these forces are to scale and they're the same size, which means that it's probably falling at its terminal velocity. So our 4 marking points, we're firstly going to go that the ball is falling. Were the ball moving up, then the downward arrow would be larger than the upward arrow, as the ball would be slowing down as gravity acted upon it. Were it falling down and not at terminal velocity, then the downwards arrow again would be larger than the upwards arrow as it accelerates downwards. So therefore it must be at its terminal velocity. So for our second marking point, we would say at terminal velocity. The reason we know this is because the forces, and we'll name them as air resistance and gravity, have the same size or magnitude. So therefore we know there will be no acceleration. And you can see clearly our 1, 2, 3, 4 marking points. Okay, question 2. The diagram shows the forces acting on a parachutist in free fall. The parachutist has a mass of 75 kilograms. Calculate the weight of the parachutist. The gravitational field strength equals 10 newtons per kilogram. Show clearly how you work out your answer and give the unit. So we're going to use the equation weight equals mass multiplied by gravitational field strength. Again, we're in standard units of kilograms and newton per kilogram, so we can just substitute those numbers in. So the mass is 75 multiplied by the gravitational field strength equals 750. Not forgetting, they asked us to give the unit, the standard unit for weight is newtons. The graph shows how the vertical velocity of a parachutist changes from the moment the parachutist jumps on the aircraft until landing on the ground. So we can see here that they're accelerating, but the rate of acceleration gets slower. At this point here, they reach a terminal velocity, which is approximately 60 meters per second, and they continue at a terminal velocity until they open their parachute. Their velocity then rapidly decreases until they reach a new terminal velocity at approximately just below 10 meters per second, which they continue at until they hit the ground and their velocity returns to 0. So the question asks us to use the idea of forces, explain why the parachutist reaches a terminal velocity and why opening the parachute reduces the terminal velocity. Again, there are 2 parts to these 6-mark questions. Number 1, we need to explain why they reach a terminal velocity, and number 2, we need to explain why does opening the parachute reduce the terminal velocity. So we're going to divide this up into 2 parts. So the first part will be about reaching a terminal velocity. So when the parachutist, here's my parachutist, leaves the aircraft, the main force acting on them is their weight or gravity forcing downwards. As the parachutist starts to fall, this force will remain the same, but they'll start to experience a smaller force of air resistance in the opposing direction. At this point, they're accelerating. Eventually, they'll reach a point where the air resistance is equal to the force of gravity. This is when they will reach their terminal velocity. And here you can see how we're going to pick up at least 3 marks to help ourselves out to that question. We then need to explain, why does opening the parachute reduce the terminal velocity? So when they open the parachute, the air resistance massively increases due to the large surface area. So opening the parachute increases the surface area, which increases the air resistance. Therefore, the resultant force is going to act upwards. And this will slow down or decelerate the falling parachutist. Eventually, they'll slow down enough that the air resistance will equal the gravity or the weight, and they will therefore reach a new, lower terminal velocity. C. A student wrote the following hypothesis. The larger the area of a parachute, the slower a parachutist falls. To test this hypothesis, the student made 3 model parachutes, A, B and C, from one large plastic bag. The student dropped each parachute from the same height and timed how long each parachute took to fall to the ground. The height that the student dropped the parachute from was a control variable. Name one other control variable in this experiment. Now there are many different control variables that you could say, but one of the most obvious ones is the mass of the modelling clay. It would be unfair and an unreliable experiment if they had different amounts of modelling clay. Again, we like to say the mass of the modelling clay, not the amount of the modelling clay. We want to keep those answers scientific. Other things that you might think of would be the material that the parachute is made from, maybe the number or length of the strings, or any other reasonable variable. Use the student's hypothesis to predict which parachute A, B or C will hit the ground first. So for this answer we need to use the student's hypothesis, which is up here. The larger the area of a parachute, the slower a parachutist falls. So we can see that C has the smallest area and therefore should hit the ground first. So the answer they're looking for is C. And the reason being, it has the smallest area, so will fall quickest. So there we have the answers to those questions. I hope you did well.